Hi everybody, this is our next section in chapter 2, and it is section 2.2, and it deals with patterns and inductive reasoning. So now we're going to take a look at different logic to understand patterns, which we looked at briefly in chapter 1, and then we're going to look and talk about inductive reasoning, form conjectures, and find counterexamples in this section. Okay, so we're going to review kind of what we did before. We looked at finding the next number in a pattern using logic. So we're going to look at the next number, or the numbers in the pattern, and then see if we can predict the next number in the pattern. So again, we talked about before, when we are looking for a number in a pattern, first I look at my numbers to see, are they increasing or decreasing? And if I look here, I see I go from 3 to 4 to 6 to 9, that my numbers are increasing. So I'm going to look at addition and multiplication first to see if I can find the pattern. I always tend to start with addition. Again, it's a little bit easier. So here I can see to go from 3 to 4, they added 1. To go from 4 to 6, they added 2. To go from 6 to 9, they added 3. To go from 9 to 13, they added 4. And 13 to 18, you would add 5. So right away, I can see a pattern forming here. They're increasing, they're adding numbers, but they're increasing by 1 each time. So if they went from 13 to 18 and added 5, that means to get to the next number, we're going to add 6 to 18. So 18 plus 6 will give me 24 for my next number. All right, now we are going to look at our next pattern. And this pattern we are increasing. And let's see, to go from 3 to 6, if I look at addition, I know we add 3. But to go from 6 to 18, you add 12. So it doesn't look like it's increasing by a certain pattern with addition. But if I look at multiplication, to go from 3 to 6, I multiply by 2. To go from 6 to 18, I don't multiply by 2, but I do multiply by 3. Let's see here, 18 to 36. I wouldn't multiply by 3, but I would multiply by 2 again. And then 36 times 3 will give me 108. 108 times 2 will give me 216. So that means, looks like we're alternating. Multiply by 2, multiply by 3, multiply by 2, multiply by 3. So since we multiplied by 2 here, that means I'm going to take and do 216 times 3 to find the third, or the next number in the pattern. And 216 times 3 will give me 648, and that will be the next number in the pattern. All right, now one thing that we used when we were finding the next number in our pattern is something called inductive reasoning. Inductive reasoning is the process of arriving at a general conclusion based on observing patterns or specific examples. A lot of the times for inductive reasoning, I kind of think of this as like little kid philosophy, and I'll talk about that in a second. They have limited experience in the world, and so they make general conclusions based on specific examples that they see. And the one thing to know about inductive reasoning is it's a great way to draw conclusions, but they're not always true. We're not always certain that they're true. So our conclusions that we draw, they're called conjectures or educated guesses, or like a hypothesis. I have 2 little girls, and earlier this year, when preschool started for my youngest, my oldest, it started on September 10th, which wasn't the same day that school started. So my oldest was like, oh, well, if, her sister's preschool starts on the 10th, then all preschools must start on the 10th. So she took a very specific example. So she went from a specific example and made a very generalized statement. So inductive reasoning always goes from specific to general. Okay, now what I would like you to do is I want you to look for the pattern in these numbers and then use this pattern to predict the next number. And sometimes when we're looking at patterns, you may see things differently than someone else. It doesn't mean that it's wrong. As long as you can explain the pattern and it works to find the next number, then it is an acceptable pattern. So pause the video for a second, see if you can find the next number in each pattern. B is a little tricky, but you can do it. All right, welcome back. Hopefully you guys paused the video and you're looking to find the next numbers. So if we take a look at A, first we have the numbers 1, 1, and then we have 2, and then we go to 3, we have 5, 8, 13, and 21. And what I'm noticing here is to get the next number in the pattern, you add up the two previous. So like 1 plus 1 will give me 2. 1 plus 2 will give me 3. 2 plus 3 gives me 5. 3 plus 5 will give me 8. 5 plus 8 is 13. 8 plus 13 is 21. So that means to get the next number, I'm going to add 13 plus 21. So I am going to end up with 34 as my next number. Now, some of you may have recognized this. This is actually a famous pattern in nature that we find all the time, and it is called the Fibonacci sequence. So if you recognized it, great. If not, look it up. It's called the Fibonacci sequence. Make sure I spell it correctly for you. All right, the Fibonacci sequence. Okay, now for B. This one's a little bit harder because if I look at just trying to do addition here, if I want to see the difference between 23 and 54, and I'm just going to subtract. I'm going to take 54 minus 23, and I end up with 31. But if I take 54 and I add 31 to it, oops, 31. That gives me a 5. It gives me 85, which is not 95. And if I took 85, or even if I took 95 and added 31, it doesn't quite work. But with this one thing that I did notice is that as we're looking at these, I know that if I add 2 and 3 together, I get 5. And then I notice that we have 3, and then my second number here is 4, and then it's 5, and then it's 6, and then it's 7, and then it's 8. And if I add 5 plus 4, I get 9. If I add 9 plus 5, I get 14. If I add 1 plus 4 plus 6, if I add all the digits together, it gives me 11. If I add 1 plus 1 plus 7, that will give me a 9. So our next number, I know, at least based on the pattern that I'm finding, it's going to end in a 9. And to get the first two numbers, I'm going to add 9 plus 8 together, and it will give me 17. So I found 179. You may have found a different pattern. I've had students in the past find different patterns. It all depends on how you look at the numbers. And as long as it makes sense and you can explain it, it's a valid pattern. Okay, so now we're going to use inductive reasoning to draw the next figure in the sequence. We have two patterns going on here. So we start off, I'm going to look at the shapes. I'm alternating. We have circle and then square, circle and then square, or rectangle. So I know the next figure in this shape is going to be a circle. And then I do notice they all have 4 quadrants in them, and they're all oriented the same way. So I'm going to draw that. But the orientation of the dots within the pattern seems to shift. So here, the first dot is on the right, but then it shifts up to the top. And then it moves over to the left, and now it's at the bottom. So what I see is the dots are rotating counterclockwise by 90 degrees each time. So that means if it's on the bottom here, it's going to rotate, it'll rotate it'll be right here, and the 2 dots, so it'll be right back to where it started from. We'll have our 3 dots here. Okay, so that is what our next pattern will look like. Okay, so here we are going to do the same thing. We're going to look at our information and form conjectures or hypotheses. So we're going to look at the circles, study the pattern, and answer the questions. First, they want us to make a conjecture about the, make it a little bit better, there we go. Make a conjecture about the 11th circle. So if I look at my circles and I want to know the color, I'm going to say, I think it's supposed to be red. Red, blue, red, blue. And I notice this is the first circle. That's the second, the third, the fourth. The 5th one would be red. The 6th one would be blue. And I'm noticing here, all my odd numbers are red. All my even numbers are blue. So I think that the 11th circle will be red. All right, make a conjecture about the number of regions in the 11th circle. So for this one here, let's see here. This one has 2 regions, then there's 4, and then we have 6, and next we have 8. So it looks like it's increasing by 2 each time, and it would be the instance, like, so this is circle 1 times 2 will give me 2. This is circle 2 or pattern 2. 2 times 2 would give me 4. This is the 3rd circle, 3 times 2. So it's the number in this pattern times 2. So I'm going to say there should be 22 regions in the circle. Now they want a conjecture about the appearance of the 11th circle. Well, we said it should be red with 22 regions. All right, and then our last thing, they want us to make a conjecture about the appearance of the 30th circle. Well, I know that 30 is an even number, so my even numbered circles are blue. And then if I take 30 and I multiply it times 2, it should have 60 regions. Okay, so the last definition and the last thing we're going to look at in this section is finding a counterexample. We talked about inductive reasoning, how it's a great form of reasoning, but it's based really on your observations, information that you've gathered. Your generalizations that you make from your specific examples, it's not always true. One way that to prove that it's not true is through a counterexample. So a counterexample shows that a conjecture is false or incorrect. I used to teach math in middle school, and middle schoolers are infamous for loving to prove their teacher wrong, so they always wanted to find a counterexample. And all you have to do is, if you have a conjecture, to show that it is false, is to find a counterexample. So here they want us to find a counterexample that shows that the product of 2 numbers is always greater than either number. So product, remember, means the answer to a multiplication problem. So the product of 2 numbers is always greater than either number. So like if I did something like 2 times 3, it is definitely, that is greater than either number. But what if I did something like 0 times 7? My answer would be 0. The answer is not greater than either number. It's the same as, 0 and less than 7. So this would be a good counterexample. We could do something with negatives, like I could do -2 times -3. Remember, 2 negatives make a positive number. So that answer is greater than either number, so that's not a good counterexample. But let's try like -1 times 5. That would give me a -5. -5 is actually less than 5 and -1, so that would be a good counterexample here. All right, our last one, they want us to find a conjecture for all apples are red. Most apples are red, but I can think of there are green apples, like a Granny Smith apple is green. So that's all you need to prove that your conjecture, your hypothesis is false. That is it for this section. Have a great day.